Thanks for joining me at ScalaCon. And today I would like to talk about Typelevel and specifically the past, the present, and the future of Typelevel. And in an earlier version of this talk, it was called A Brief History of Enterprise Monads, which is based on a joke about the conference called FlatMap. And what does enterprise monads mean? Well, in the old times, when only Haskell was around, monads were considered to be a playground for scientists and academics. And at the time, nobody really realized that they would be widespread use in industry. And now we have enterprise monads, so they are only also used for business purposes. So in this talk, I would like to chronicle the history of how we got from the left side, from the science side, to the right side, to the business side. And the history of Typelevel starts in the year 2013, the humble beginnings. So the Northeast Scala Symposium is a conference that's happening every year in the Northeast of the United States. And 2013 was my first time attending it. And there, a bunch of people, me including, gathered and thought, well, maybe we should start some kind of initiative about functional programming in Scala. And it is very important to note that at the time we were not really organized at all. So it was just a bunch of people who got together and wanted to produce some open source software. And we didn't really have any clear world domination goal or anything like that in mind. But ultimately, we ended up with, as of now, over 70 projects and a vibrant ecosystem. And while we didn't have any kind of business goals in mind, we did have a central theme. And that theme was Scala idiomatic functional programming. Now, functional programming, of course, many of the patterns that we're using in Typelevel Scala, they're not new. We have not invented those patterns. So monads, for example, they come initially from category theory, but they've been popularized for programming in Haskell. And they've been in use there for many years. So why couldn't we just copy that? And to some extent we did, but Scala is a different language in Haskell. So one of the qualifiers of that theme is that we wanted to have as little Haskell as possible. So it should just work in Scala somehow. And we had to make some concessions with that respect. So not everything could be copied one-to-one over from Haskell, but we had to somehow get creative to some extent. And I will also try to explain some of this creativeness, some of this creativity in this talk. Furthermore, as little runtime overhead as possible. So while Scala supports type classes, they have to be encoded to be used. But this encoding also is a bit hostile to the JVM. So the JVM doesn't really like functional programming that much, or at least it didn't used to like. Now it's a bit better. But at the time, performance was a really big concern. And not for everyone, though, but many people thought we should try to not sacrifice performance too much. And finally, it should be as safe as possible. So mishandling the API should be made very hard. And all of these three qualifiers together make it a bit difficult. So we cannot get all of those three at the same time. But I think over the years, since 2013, we have iterated quite a lot and have now arrived at a particular state that is very nice to use. And many of the principles that have been developed in the context of Typelevel and the broader functional programming ecosystem Scala have also found their way into Scala 3. So to some extent, Scala 3 is also a product of the community, that many features there have been inspired by the functional programming community. Now, what we did not expect in 2013 was that a lot of major companies have adopted Typelevel products. So this is a screenshot from the website of the Cats Effect. I will talk about Cats Effect in a bit later on this talk. And you see here big companies like Disney streaming services or Comcast or Philips. which have adopted a cats effect and are running those libraries at big scale in production. So to me, that was quite surprising that those libraries ultimately ended up being quite successful. But of course, it was a long road there. So now I'm going to switch back gears into the past and would like to chronicle a bit how we got there. So let's start out with cats, the premier functional programming library in Scala. I already mentioned that type classes have been around for a while, and type classes are a really, really useful programming tool, and they've been pioneered in Haskell. And in Haskell, the language has first-class support for them. So if you want to define a type class, you just write the class keyword, which means something completely different than in Java. But here we have an example of the monoid class, and you see that there's some kind of arrow that says semigroup implies monoid somehow. It's not an implication, it's somehow like a subtype relationship. And this monoid class has a few functions in it. So there's the empty function, and there's the concat function, and there's even a default implementation of the concat function. So to some extent, using and defining type classes in Haskell is really easy. It just works. The type checker knows about this. This is a picture of the working group that defined Haskell, and you may see a few familiar faces on this picture. So I guess it is quite easy to spot Philip Wardlaw in this picture. But there's also Simon Peyton-Jones and a few others. And this is the working group that influenced the Haskell design, or that defined Haskell. And now we are trying to build on the work of those people. And here's a picture from the FlatMap conference. So those are basically the somewhat equivalent people in Scala. So we have here, for example, Miles 7, who was on the forefront of type class and other kinds of encodings in Scala. And we have Eric also, who's behind Spire. We'll also talk a bit about Spire. But somehow we just had to, like the Scala folks just had to make sense of what the Haskell folks did. And of course, there's many more people not pictured here that have influenced this to a great extent. So type classes in Scala, okay, simple, right? So we just need to encode them somehow. However, there's a few catches, not just one catch, but a few of them. We have multiple inheritance for type classes. So in Haskell, you can easily define type class hierarchies that have a diamond in them. So one type class extends a particular type class via two different means. There's actually quite a few examples about this. And this is a bit difficult to encode in Scala. Scala does have multiple inheritance, but it does not have a built-in notion of the so-called confluence property. So in Haskell, if you have such a diamond in your type class hierarchy and you define instances that correspond to that, it doesn't matter which way you go up the hierarchy, you always end up at the same instance. So the type checker can just choose one or the other. In Scala, however, this is ambiguous, and the type checker will complain that it doesn't know which path to pick. And this comes up quite frequently if you're using, for example, cat's effect, or you're programming very abstractly using monads. So basically, we just had to find a way to disambiguate that. And there's many different encodings out there. And it's not entirely clear which is the best one. So all of them have individual advantages and disadvantages. But there's one that has been settled on in cats. Then the syntax. So Scala has traits and objects. Sometimes it can be a bit noisy and a bit verbose. So Scala really fixed a lot of that. But it's still sometimes a bit of a hassle to define complicated instances for type classes. And then the confluence property that I also mentioned, there's even a global confluence property in Haskell. So in Haskell, in every Haskell program, you have at most one instance per type per class. So it is not possible to define two different monads for a type, for example. And this is enforced by the type checker. But in Scala, you can. And if you import both of them, you get an ambiguity, or maybe you just import the wrong one because you didn't know about the other one. So that is also a problem. This is an actual picture of Adalbert. So Adalbert was thinking about this problem very hard quite a while ago, and he was as confused as many others, but then he decided to channel this confusion into an actual research paper. So he wrote a paper that's called The Limitation of Type Classes as Subtype Implicits. And subtype implicits is basically what we're doing right now. And he very carefully described all the pros and cons of those different encodings. And this was an important inspiration for the design going along the way. So we somehow found some way to encode type classes in Scala. And the problem was still that different projects had different ideas, even across the type level spectrum. Because there wasn't just the fact of the type checking and the confluence and so on, but we also wanted to define operators. So when you have a monoid for something, you might want to use the plus operator because that's idiomatic Scala code to use operators. Now, Michael Pilquist in 2015, he started a Simulacrum project, and his goal was to ensure that all the different projects have a consistent encoding and there's no boilerplate involved anymore. And that was a very noble goal. And he achieved that goal. And I will show now how he did that. So the idea is for a library author who defines type classes, you import Simulacrum and then you slap an annotation called @typeclass on your type class. And you also slap an annotation on each method that you want to provide syntax for. So here in the semi-group, we use pipe plus pipe for appending. And every time you have an instance of this trait for a class, you can use that pipe plus pipe operator. So very simple, right? One annotation per type class and one annotation per method where you want syntax. And this is a macro, Simulacrum. And this macro does something under the hood. And I'm going to show you now what it does under the hood. So I just want to tell you what Michael did here for all of us that we didn't have to. So first of all, it outputs a companion object with the same name as the class. And it gives you a convenient method to obtain an instance of your type class. More output, it also defines a trait that is called ops. And it contains helpers for the syntax. But then you also need an implicit class that enriches a particular value with those operators. And it gets more complicated because you have to do that in the presence of subtyping. So a monoid is also a semi-group. So when you have an instance of a monoid, the syntax of semi-group should also be available. So yet more output is to do this exactly for all the different types involved. And this is an actual picture of Michael in the basement of the Comcast building in Philadelphia when he was trying to explain how he built that macro. Now, it did work. So there was a lot of complicated things going on under the hood, but we can write X plus Y when we have a semi-group or monoid instance in the scope. So now we have idiomatic Scala code, and the encoding is basically hidden from us. So it works so well that there's hardly any time where it breaks down. Of course, the compile failures might be a bit inscrutable sometimes, but it is used by cats and tons of third-party libraries that are even outside of Typelevel. So I would say that Simulacrum did a really good job at unifying all those different aspects together and giving us some way of writing those type classes without too much boilerplate. Now, unfortunately, Scala 3 has a completely different notion of what macros can do and how macros should be implemented. So Simulacrum is only relevant for Scala 2. For Scala 3, there's a different mechanism of getting the same thing done as Simulacrum would do. And the issue is that we still have to support both Scala 2 and Scala 3, so we have to sort of use a bridge technology to get that to work. But ultimately, when Scala 3 only support, when we only support Scala 3, when we drop Scala 2 support, then we can fully leverage the features that Scala 3 offers and make it even simpler. but that's currently not yet on the roadmap. By now, we still have to support Scala 2, but maybe a few years down the line, we can fully leverage the new syntax features from Scala 3. So let's talk about Spire now. Spire is one of the original libraries of Typelevel, so one of the original 3. But my impression is that many people don't even know it and don't know how powerful it is, what you can do with it. Spire is a library for numerics in Scala, and it started out as an SIP document in 2011. I'm not sure how many people actually remember the zip process at the time. So it didn't end up, I think, as a zip properly. It was just a draft that Eric at some point presented at the conference. So here's also a picture of Eric at any Scala. However, instead of pursuing the proposal as an official Scala standard, it evolved into a dedicated library. And the underlying idea was that Eric wanted to do generic numerics in functional, but also fast. So basically having your cake and eating it too. The Scala library does not really have a lot of tools for numeric programming. So it was really filling a niche at the time. And the Spire library contains a lot more than just basic number abstractions. So it also defines custom number types, and it also defines an algebraic hierarchy and some algorithms and so on. So it really became the go-to library for any kind of fast and safe functional numeric programming. I want to pick out one aspect because Eric is one of the few people who actually care about performance a lot and are willing to go to great lengths to ensure performance. And what Eric found was that Simulacrum and the entire encoding behind it didn't solve the performance issue of type classes. So that's not a specific issue of Simulacrum, but that's a general problem of encoding type classes in Scala. So when you write x plus y in your code file, what Simulacrum or other encodings would do is applying an implicit conversion to x to a particular obstrate, which I showed earlier, and then calling the append option on the type class instance. So you have many indirections. This is basically what the compiler generates. So you first convert x to a particular object, and then you pull in another instance, which you don't see here because it's implicit. And the issue is that you have at least 2 allocations while doing that. And one option would be to just say, well, the JVM is going to optimize all of that away. Why do I care? Just, do it for me. But that wasn't good enough for Eric. So in Spire, he went a different way. It was called Machinist, and it was split out of Spire in 2014. So it's actually a bit older than Simulacrum. And the idea behind Machinist was that it could serve as a generic macro library that would do compile time optimization of these kinds of calls. So now, 2020, it was archived and reincorporated into Spire because it didn't turn out to be as generic as people would have liked. But in general, it could optimize, or it can still optimize a lot of things. And again, Scala 3 has more mechanisms for that. So there's proper inline definitions, and we can leverage those to get to a better performance. However, inlining is also not a silver bullet. So too much inlining can also prevent performance gains on a JVM. So this is not a clear-cut solution. And as always, it is very important to benchmark the code to find out where the potentials are for optimization. Moving on to the next big library is Shapeless. And Shapeless also has an interesting history of how it was conceived and created ultimately. It also started out in 2011, so that was a very fruitful year for Scala 10 years ago. It started as a series of talks. So here we see Miles 7, the author of Shapeless, or some people argue that his dog actually authored Shapeless, so maybe his dog is just telling him what to type in this picture. And it also was inspired by Haskell. There is a Haskell paper that's called Scrap Your Boilerplate. And the basic idea of that paper is how to abstract over data. So in Scala, we use case classes all the time. We use field traits that inherit case classes, and have all of these big domain models that are completely modeled as case classes, and they're nested and so on. And sometimes you just want to dump all of them to JSON or to parse them from JSON. And this is a very mechanical process. You have to write a lot of boilerplate code. And the idea is that you want to get rid of that boilerplate code as much as possible. And the concept behind this is called type class derivation, and Shapeless pioneered that in Scala. And it will come to no surprise that, again, many of these concepts got incorporated into Scala 3. Lars was even involved in the development of the Scala 3 compiler at some point. And this can be now done a lot easier. So the Shapeless library for Scala 3 is a lot smaller than the Shapeless library for Scala 2. And in fact, for many use cases, you won't even need the Shapeless library anymore. You can do it with just the tools that the Scala compiler gives you. Now let's look at an example of how the type class derivation works and what it does. So I mentioned already the use case of JSON, but maybe let's also look at another use case. So for JSON, you have to write boilerplate code to serialize and deserialize. But another use case would be comparing a bunch of case classes. And then you suddenly find yourself writing the same boilerplate over and over again. So the idea was to abstract all of this away. And the solution for that is the concept of heterogeneous lists or H-lists. And I have here a very simple domain model that contains a bunch of case classes, an account, and the account is owned by a person, and the person has an address, and the address is in a country, and the country is, again, a case class. And we can now translate those case classes into heterogeneous lists, which are lists containing types. And this would look like that. So we define an equivalent type, count, and it's a person and an int. And you can read that type sort of like as a tuple. So it's a tuple of person and int. And the tuples here in these heterogeneous lists, they are on the type level, and they have arbitrary arity. So you can have tuples of arbitrary length, which is not something that you can easily do in Scala 2. So in Scala 2, you had this infamous upper bound for tuples. This can be abstracted away using these H-lists. What happens there is in the Shapeless library that the conversions between those case classes, so what you see on this slide, and the H-lists is automatically generated. So this is, again, a macro that's working under the hood and converting back and forth. And then using this H-list representation, it's a lot easier to produce type class instances for JSON encoding, decoding, or comparison, for example. This is used quite heavily in practice. So a lot of libraries are employing these abstractions. So one possibility would be to use Scala check Shapeless, which is an integration between Scala check and Shapeless, as it already says on the tin. And it can produce instances for arbitrary in Scala check. So you can easily test your domain model with that. There's also the Thirsty library, which is the prime library for JSON conversion in the Typelevel ecosystem. And we also have other libraries there. PureConfig will integrate with the Typelevel, the Lightbend config library. And then we also have Kittens, which allows you even to derive functors and other higher kind of type classes. So this is quite a success story. It turns out that this mechanism increased compile time quite a bit. So there were also strategies to counteract that compile time performance issues. And again, Scala 3 makes this a lot easier than at a later point. Many of those libraries that support this derivation mechanism had to be rewritten for Scala 3, but ultimately I think it was for the better, because the new abstractions are easier to use and more understandable. Moving on to Cat's Effect, which is the library for asynchronous and concurrent programming in Scala. And its full history is almost impossible to trace. So there's this book that's called Functional Programming in Scala. It's the red book, and I think second edition is currently being written. And it touches upon these topics a lot. And the library itself draws from a multitude of influences, so there are influences from Haskell, from many other programming languages, stealing some of the concepts. And basically, the rise of asynchronous software construction, which is now ubiquitous, is supported by the Cat's Effect library and the concepts behind it. So let's take a look at the mechanisms that it provides. So this is a picture from the very nice ImpurePix, who keeps drawing those cool explainer graphics. So check out his website at some point. Cat's Effect 3 is now the third iteration of the library, of course, and it gives you abstractions over particular programming features. So we see here, for example, the sync type class, and the async type class is a subclass of that. Then yet another subclass is temporal, and you see that each of those classes extends your code with particular additional features. So if you want to have access to a clock in your code, then you would demand the instance of clock or an instance of temporal, for example, because temporal inherits from clock. If you want to have access to some kind of fresh name generator or some kind of token generator, you would demand unique, and so on. So you can pick and choose what features you need. And Cat's Effect 3 also provides a default implementation, which is just called IO. And IO provides most of those features. And you can either concretely program against IO, or you can also use alternative implementations. So Monix is another library that I couldn't mention in this talk for concurrent and parallel programming. And Monix also integrates with Cat's Effect, providing all of those abstractions with a type that gives you a bit more flexibility in how execution is being done. Now, I've talked about the technical aspects quite a bit of the major libraries. And of course, again, there's over 70 projects, so I couldn't possibly comment on all of those and how all of those fit together. So I would like now to discuss a bit the community and important milestones in the community development, and then finally move on to the future part. So how you can help shape the future of type-level and functional programming in Scala. So since 2013, when we created the project, or basically creation of project was I bought the domain typelevel.org and then put some stuff on the website. So one of the first pivotal points was 2014 when we forked the Scala compiler. So there was for quite some time a type-level Scala compiler, and it was used as a playing ground for new language features and for fixing long-standing issues where there was no clear fix, but we wanted to try it out anyway. And initially there was a bit of a rivalry between the official and the type-level fork of the Scala compiler, but I think ultimately it was a good idea to have this experimental playing ground. And I think there was a lot of cross-pollination between the two projects. I'm actually unaware of how many people ever use type-level Scala in production, the type-level Scala fork in production. But since it was shut down at some point, I hope everyone has migrated back to the official Scala releases. 2015, Eric started the CATS project, which was a reaction to a community fallout. And CATS is nowadays the premier functional programming library, replacing Scala Z at the time. 1 year later, 2016, we organized our first conference, or even conferences. So there were 2 conferences, one in the US and one in Europe. And while they weren't as big as, let's say, Scala Days, for example, it was still an important jump, an important leap forward for the community. Same year, I joined the Scala Center Advisory Board as a community representative next to Bill Wenners and a few people from industry. And this gave us a seat at the table to determine what the Scala Center was going to work on. And that was also very fruitful collaboration. And the Scala Center and Typelevel have long maintained quite strong community bonds. Yeah, next year, already mentioned 2017, we should shut down the Scala fork. It was officially shut down, I think, only in 2020, but it was very clear already in 2017 that development has stalled, and it basically served its purpose. Same year, we also released CATS 1.0.0. And interesting enough, even though CATS is now at version 2 point something, it is still binary compatible for the most part with CATS 1.0.0. So this is quite an important fact for businesses seeking to use Typelevel libraries, binary compatibility. And many libraries have been experimenting with how to do binary compatibility in Scala. And I think ultimately many realized that we just should do semantic versioning like everyone else does. And it is quite hard to maintain binary compatibility. So Scala CATS 2 is even binary compatible across a major semantic versioning number. So from 2 to 1. But still, it turned out to be tremendously useful because you didn't have to rebuild the entire ecosystem from scratch when it came around. 2 years later, 2019, we launched a donation campaign. We have now a donation page in Open Collective. And there's actually quite some money flowing in. And we've also paid quite some money out for people who are working on some long-standing tickets. There was one ticket, for example, for Scala.js support in HTTP4S, and many other things that were being worked on. And a year later, 2020, last year, the Typelevel libraries were at the forefront of Dotty development. So we adopted a release train for Dotty release candidates quite early on. Of course, there were other libraries that were even earlier than us, but at some point we decided to do the full release train. So every time a new release candidate came around, we did the entire thing, starting from Scala check, going all the way to the downstream libraries of CATS. And this meant that we could detect problems quite early on and also have maintained good collaboration between the development team behind Scala 3 and our libraries. This is a view of the website, and the changing times can also be seen from the design of the website. So in 2013, it was really bare bones. So I put that together in a train, taking a train in Germany, and I just had this bootstrap theme and put together some very simple GitHub pages. And here you see the original 3 libraries behind Typelevel. So it's Scala Z, Shapeless, and Spire. Then the next year, the page still looked as ugly as before, but a few more libraries have joined. Scala Check is, I think, now one of the most foundational libraries in the ecosystem. So everybody and their dog requires Scala Check for testing. So every time a new Scala release comes around, we had to be quite early, sometimes even just a few hours after the Scala release to also release Scala Check. Then next year, 2015, still a long list of projects, but note the absence of Scala Z. And at the time, CATS was not yet on the website. Then next year, 2016, when the first events came around, we had a big overhaul of the website. And this is also what you see today. So it looks a lot more professional now, instead of my very stupidly put together bootstrap website. You see here also the upcoming events. Now, of course, 2020 was not really a good year for events. So there weren't really any big things happening. But I have to qualify that. So many people put together a lot of great online events, but I think from our side, from our side, we didn't really put together much on the website, and basically giving it to the hands of, for example, the team behind any Scala. There's also a redesign in progress. So this is a sneak peek. So the fine folks at 47 Degrees have supported us for a long time already. And they are now helping us to relaunch this. So this should hopefully happen sometime soon. And speaking about the future, so I want to circle back initially to the joke about the enterprise monads and finally tell you how this joke came about. So this is a T-shirt from the FlatMap Oslo conference, and it's a long-standing joke that Scala is kind of an enterprise monad language, because we already have the JVM, which is like this enterprise platform for server-side development. And then a bunch of Swiss people came around and started putting monads on the JVM using Scala. So basically what it says here is, you can flat map while you enterprise. And at the time when this shirt was when these shirts were printed, everybody found it hilarious. And now I still think it's hilarious because it's true. So we finally achieved that. If you see big companies like Comcast or Disney streaming services using those monads in their big enterprise applications, then yes, we have indeed flatnet while we enterprise. And I think this is also an opportunity for future development. So a lot of people talk about sustainable open source development. And of course, funding open source is an important component, but developing open source is another important component. So of course, there can always be more pull requests, and there can always be more maintainers who review those pull requests, because most of the time this is done by volunteers. And especially with the 70 plus projects, getting a release train to run is really difficult. And you need people who at some time are just all hands on deck. So we are talking about a new Scala 3 milestone. Bam, everybody needs to run those releases. And the more people who can do that, of course, the better. So this is really an opportunity for people who are using the ecosystem, that also applies to the broader Scala ecosystem, to join us in shaping the future of open source, in particular, the future of functional programming in Scala. So take that as an invitation to send pull requests. Those pull requests can, of course, be scratching your own itch. So there's no obligation to work on long-standing issues, but of course, it would be better to work on long-standing issues, and this will benefit the entire community. And as a closing note, I have another joke. So Rob here on the first message on Twitter is saying the answer is almost always .traverse. So traverse is a very important function in functional programming. And then we have James replying, we are not flat mapping that shit anymore. And then Stu finally says, traverse is flat mapping that shit on our behalf. And I think that is a good summary of what the CATS library is about, flat mapping that shit on our behalf. And with that, I'm done and be happy to take questions.
Lars, thank you so much for that talk. And now we will jump into some questions. So let's get to the first question. What are some of your favorite now dormant projects associated with Typelevel or adjacent to the ecosystem?
Yeah, so I've already given some part of the answer. So Spire is a project I like very much, and I think it should get a lot more attention than it currently does. It is used in lots of libraries transitively. So, for example, Spark depends on Spire indirectly. So many people actually have Spire in their class path. I wouldn't call it dormant or dead even, but it's definitely not as actively developed as CATS. So to reiterate my kind of call at the end of the talk, please send us your pull requests, and also please send us maintainers who will take a look and give the library some love. Apart from that, there's a whole bunch of other libraries, smaller ones that are used to be quite common, but many of them will also become dormant, I think, in the future when more people migrate towards Scala 3. So Simulacrum is an example. In Scala 3, it will be done differently. And I guess some of these tools, or Kind Projector, for example, is also a thing. It's a compiler plugin that was used quite heavily in Scala 2, in old Scala 2 versions. And now I think with everybody migrating, hopefully soon, some of those will become out of date as well.
Awesome. Thank you for elaborating on that. That's a great answer. All right. Our next question is, can you say what the plans are for HTTP4S? Do you plan to make it a full type level product?
Yeah, so I think this question references the distinction we still have on our website officially that there is a full in incubator projects. I think we started this idea with these incubator projects already many years ago, like projects which might not have good documentation yet, which are still trying to get integrated into the ecosystem. They can still get a spot basically at the seat, a seat at the table. But HTTP4S is a great example because it's this big so it's a big vibrant community around it, and it's being used in production quite a lot. And now it has Scala.js support and so on. So actually, the point is that I think we should really think over this incubation notion. I guess it's not really useful anymore, and we should just make it a full one, or maybe we should just get rid of the distinction altogether. So HTTP4S is really, really an important library, and to call it incubating isn't doing it justice.
Nice. Yeah, that's nice and clear. All right, I think that's all the questions we have. So thank you again for your presentation today, Lars, and thank you for taking
Thanks
the
for
time
having
to
me.
answer the questions. Absolutely.